Right, we briefly started talking about this yesterday, but today we're going to talk more about normally distributed data. The learning targets are to be able to use the empirical rule to estimate probabilities of normally distributed data, but also to be able to calculate those on your calculator, including ones that don't come out exactly on the standard deviation number, a whole number of standard deviations. We are going to talk about z-scores, and you need to be able to calculate a z-score. The formula for that is on your reference sheet, okay, your gray reference sheet. But I will tell you that I'm not going to use a z-score table. We're just going to rely on the calculator to do all the fun. All right. So data is normally distributed if it has something like this shape. It doesn't have to be that exactly. It could definitely be more like this or something, okay? But it's bell-shaped. It's the mean, median, and mode are roughly all at the same place. And 100% of the values fall underneath the curve. Okay. We talked yesterday about how you could come up with that. There is a crazy formula that will give you that curve, but your calculator will graph it, but we'll talk more about that in a minute. For every normally distributed random variable, the shape and position of the normal distribution curve are dependent on the mean and standard deviation. For example, in this figure on the left, there is a larger standard deviation, so the data is more spread out. Okay? In this, on the right, this example over here, the distribution is the same, but the average value was significantly less on the blue one. Okay? So the standard deviations make it the same width. Right, so let's talk about what in the world this actually means. We're going to use this crazy rule. Where's my clear ink? Yeah. We are going to use this idea to estimate, okay? The area under the normal distribution curve between two data values represents the percent of values that would fall within that interval. The empirical rule can be used to describe areas under the normal curve that are 1, 2, or 3 standard deviations away from the mean, okay? So if we're looking at data that's exactly within 1, 2, or 3 standard deviations, we can use this empirical rule, and it is still an estimate, okay? We're going to do it on the calculator eventually. So the empirical rule is also known as the 68, 95, 99.7 rule. You don't have to memorize that because it's on your reference sheet, this exact chart. All right, it says this is the mean within 1 standard deviation to the right and 1 standard deviation to the left is 68% of the data, or 34% each way. Right? Within 2 standard deviations total is 95% of the data. So that's another 13.5% added on to the 34 we already went each way. And if you go out 3 standard deviations, we reach 99.7% the data. So it's another 2.35% on either side. Okay. So that's what it looks like on your reference sheet. It includes this, which we're going to talk about later, how to find that on your calculator. And it includes the z-score formula, just so you know, okay? It's all there. So here's my example. The heights of 880 students are normally distributed with a mean of 67 and a standard deviation of 2.5 inches. So what I would have done if I were doing this homework question was I would have said, this is 67. If I go 2.5 either way, I'd be at 69.5 and 64.5. Did I subtract 2.5 right, guys? Yes? No? Okay. And if I go out another standard deviation, I'd be at 72 and 62, right? Because I'd take another 2.5 either way. And then I could go out one more as well, but I'm not sure we need that. It says, how many students? Okay. Approximately how many students? Okay, this doesn't ask a probability or a percentage question. We could answer as a percent first. Are more than 72 inches tall. All right, so this was my mean. This is one standard deviation each way, which is what percent? 68, okay. This is two standard deviations each way, which was 95%. So outside of that 95% is 5% of the data, which means 2.5% this way and 2.5% this way, sorry. We good? So more than 72 inches would be 2.5%. The probability of choosing someone would be 0.025 or 2.5%. This asks, though, the actual number of students. So our sample was 880 students. So we would have to take 0.025 times 880. And I don't know if you have to round that to about 22 students. Anybody type it in? Does it round? No, it's exactly? Okay. Yes. That's the third one out. I only went two standard. Great question. Okay. This was one standard deviation, two standard deviations. This would be the third standard deviation out, and that's where we hit the 99.7. It says here for the third standard deviation. Do you see that? Okay. So I only went out two because it said 72 and I had already hit that, so I didn't keep going. All right, this says what percent of the students. So now we just get to use the percentage fall between 99.5 and 69.5. Okay. If I go back, come on. What was it? 99. Sorry. Between 59.5 and 69.5. Well, 69.5 is right here. 59.5 would be this next one down if I took off another 2.5, so to 3 standard deviations. Okay. Some of you are going to want to say this is 50% plus 34 because everything below here should be 50%, right? But did we go all the way to the end? Not quite, right? We went this way 3 standard deviations. 3 standard deviations is 99.7, but it's half of that because we only went to the left, yes? Plus we went to the right 1 standard deviation, which was 34%. All right, 99.7 divided by 2 plus 34. What did I type? Some crazy business. Somebody get 83.85? Okay, which is what they say here, or about 84% of the students will fall in between there. Okay. It says down here, when you're asked greater than or less than, you need to include everything under that side of the graph. So all the way out. Okay. So let's try this example. The average monthly temperature for a city for 1 year when normally where it's normally distributed with a mean of 65 degrees. And a standard deviation of 5. So we have 70, 75, 80, 60, 55, 50. Okay, I don't draw well. Those are not even, but we're going to pretend. All right, find the probability that you fall between, the temperature falls between 50 and 70. Pretty sure that's exactly the question we just did. But we're going to pretend. Okay, what, if we go out, you could use your reference sheet, but from memory, this is 34%, okay? And all of this is 68, to here is 95, and out to here is 99.7. So any ideas? How are we going to find from here to here, guys? What do you want to subtract? In my head, I'm thinking this piece right here, 3 standard deviations to the left, is half of 99.7. And then to the right, I went another 34. Exactly the question we just did. Okay. So what did we get again? 83.85, is that right? Everybody okay? All right. The height of 200 trees in a nursery are normally distributed with a mean of 120 and a standard deviation of 16. Okay, guys, help me go. 16 more would be 136. 16 more, 152. Help. 16 more, 168. Somebody check that, please. 16 less would be 104. Oh, I don't do subtracting well. 88? These are probably wrong. Somebody fix me. 72? How did I do? Okay. I think when you're just learning this, I know a bunch of you have AP stats already, but when you're just learning this, drawing that out really helps you to understand the process. All right. Approximately how many trees are more than 136 inches tall? Well, more than 136 means forever this way. Okay? Anybody tell me, not just 3 standard deviations out, but all of it that way. So what is all of it left to the right of here? This is the mean, right? So everything to the right of the middle would be 50%. Does that make sense to everybody? And this in here was what percent? 34. So the difference is 16%. Are we good? 50 minus 34. Did I lose anybody? Okay. So 34, nope, 16, liar. 16% of the trees are more than this. Is that what they asked? It says how many trees. It doesn't say what percent of the trees. So what do we have to do? Heights of 200 trees. So we need to find 16% of 200, which would be 0.16 times 200, which you should be able to do in your head, is what? 32 trees. Okay. What percent of the trees fall between 88 and 104? That's this little section in here. How do you want to figure that out? Well, 80, and it might be written on your reference sheet, I don't know. But this is 2 standard deviations, right? What's the total of 2 standard deviations? 95%. Okay. If we maybe cut that in half, we'd have what? 42.5? Which would mean from here to here is 42.5. But we don't want this what? What's in there? Minus 34. So what does that come out? How much? Someone else get 8.5? Okay. Oh, yeah, that's right. Because off power can't, that's why it's off. Mistake number 1 for the video. 95 divided by 2 is 47.5. So this right here, this red is 47.5, and we need to take off this, which is 34. Which is the 13.5, which is what you said. Is that written right on the reference sheet somewhere? Well, it's here, right? This one shows it. But off the oh, it does show it. Yep. On the reference sheet right here. Okay. See, I don't have all those little pieces memorized. So. All right. Did we do okay on that question then? All right. Well, the empirical rule can be used to analyze data. It's only useful when you're at a specific number of standard deviations. Okay, a normally distributed variable can be transformed into a standard value or z value, okay, or z-score, which can be used to analyze any range of values in the normal distribution. This transformation is known as standardizing, and the z, we're going to call it a z-score because that's what's in my head, is the number of standard deviations that a given data value is from the mean. It's just how many standard deviations are you away? So you take the number you want minus the mean and divide it by the standard deviation. So if I go back here real quick, if I wanted to know 100, the value of 100, okay? That's not where 100 is. Just kidding. Just seeing if you're awake, because I'm not. 100 would be over here. If I want to know how far that is in standard deviations, okay? So 100 is how far away from 120? 20 units, right? And our standard deviation was, how wide were the standard deviations? 16, so this is 1.25. Did I do that in my head right? Standard deviations below. Okay. That's the z-score. That's all it is. Okay. The number you want minus, so how far away is it from the middle or the mean, divided by the number of standard deviations, the size of a standard deviation, divided by the size of a standard deviation, will tell you how many standard deviations it is. Again, a negative just means it's below the mean. A positive means it's above the mean. Everybody good? All right, so a little practice with a very basic algebra formula, but I'm going to talk through it with you, okay? This is asking, how many standard deviations above or below is a score of 65 if the mean is 50 and the standard deviation is 10? So we're at 65, the mean is 50, So we're 15 units away when the standard deviation is 10. So that's 1.5 standard deviations above, right? You can just plug it in this formula. I'm trying to talk through it as though we were actually, okay. This says if a z-score is, so now we're working backwards. Negative 0.4 is, what was the score x when the mean was 40 and they divided it by 5? So somewhere below the mean was a score, right? How would we work that backwards? Multiply by 5 and we get what? Negative 2. Did I do that right? So if we add 40, we get 38. Does that make sense? A score of 38 is below by 2, divided by 5 would be 0.4, and it was negative because it was to the left of the standard deviation. Okay. It will be, because the formula's there, and there's just a question, and it's very basic like this, okay? It could ask any one of those 4 variables, guys. You should be able to solve for any of those algebraically, but that's it. So one easy question. It might even be multiple choice. All right. Every normally distributed random variable has a unique mean and standard deviation, which affects the position and shape of the curve. As a result, there are infinitely many normal probability distributions. Fortunately, they can all be related to one known as the standard normal distribution, which is what they use to do the z-score, okay? Here it said the mean is 0 and the standard deviation is 1. So they will use these numbers down here. These are the z-scores, basically, okay? Standard number of standard deviations. So when they take that and do it on the calculator, then they can use this magical table. But our calculator has this table in it, okay? We don't need it. It calculates it actually using area under a curve. All right. So we can use normal PDF, which will tell us how far, if we put in a value, the mean, and the standard deviation, it will tell us the probability that a value falls at exactly that place, okay? The default is the z-score. We can put it in as a z-score, or we can put it in, we can put x in as a z-score, or we can put it in as the actual score. It doesn't matter. If you put it in as a z-score, then this would be 0 and 1 for the mean and standard deviation. See, this is the default, guys, when you turn it on. It says x value where the mean is 0 and the standard deviation is 1, okay? But if we can also cheat and never find the z-score, we can just put in the x, the actual mean and standard deviation, and it'll find it the same way. All right. If we're going to use the CDF, which is when you want to find, if you notice here, an upper and lower, so you want to find the area in between two things, not at exactly 1 point. So in between two values, it will default to, I think it actually says -1 E99, which just means 0, really tiny, okay, gone. To whatever upper value you put in, and it defaults to a z-score, but we can type in a value and put in a mean and standard deviation. All right, but if you have an older calculator, this is the order you have to put it in. The value you're looking for, the mean and standard deviation. For a PDF, which is a straight up probability at one value, combined probability of a range of values, you put low, high, mean, standard deviation, okay? So it's also the area under the curve, which we could show you. I used to know how to do this. How do you graph it? You guys remember? Draw. Oh, it's draw, right? Go over to draw. So you could shade the area under the curve. If I said I want to find the value, okay, I'll do an example in a minute. It'll make more sense. I'm not going to make one up. All right, so the average number of phone calls received when a customer service representative each day during a 30-day month was 105 with a standard deviation of 12. Find the number of days with fewer than 110 calls. Okay, if the mean is 105 and we want to know fewer than 110, okay, this is 110. The standard deviation is 12. Is that exactly one standard deviation above or below this? The next 105, if the standard deviation is 12, would be 117, right? So it's not. It's in the middle. Okay? So we could convert it to a z-score, which is what they did, and got 0.42, and then we could use the calculator. I'm going to vote we don't even bother with the z-score. Okay? So let me show you how to do this on the calculator. Go to second vars. Now we are doing normal distribution stuff, right? So it's right up here at the top. What was it? The call fewer than 110. So we want this combined probability, the second one, okay? And we want all the way up to how many calls? 110, right? Sorry, I have this in the way. You can't read the question. Fewer than 110 calls. So we want everything up to 110. So you can leave this default lower. If you had an older calculator, you could put 0. I don't care. And then we're going up to 110, where the mean was 105. And the standard deviation was 12. Now, we didn't bother to convert it to a z-score. Did we get the same thing they did? Right here it says 0.66, right? Okay, so 66% of the calls, which in a 30-day month, you would take that times 30 days and get 19.8. All right, I vote we move on to one that you care about. Oh, maybe you still don't care about this one. Do you have this one on your paper? Yes, but it's done. Okay, let's go through it real quick, though, because I'm going to do it a little different than they did. I'm not going to bother with the z-score. It says, on his last 20 airline trips, an employee had an average layover of 82 minutes with a standard deviation of 7.5. Find the number of layovers less than 75 minutes. All right. From 82 to 75, is that exactly one standard deviation here? From 82 to 75, if the standard deviation is 7.5? No. Okay, so we would have to do a z-score or use the calculator. All right, what do we want? Find the number of layovers. Okay, that tells me I don't want a percent, the actual number of layovers at the end of the question, that were less than 75. So I want everything up to 75, okay? Oh, wait a minute. I didn't draw that in the right place, right? Because it said the mean was what? If I'm sketching this, it says the mean is 82. So 75 is down here somewhere, and I want all this. All right, but we're going to use the calculator, and we're going to go to normal, CDF. Are you in AP Stats? Are you going to know how to do this? Normal CDF, guys, second vars, normal CDF. You can leave this or even put a 0, it doesn't matter, okay? Not going to change the decimal anything significantly. All the way down to the bottom, up to 75, where the mean was, what was the mean here? 82. And the standard deviation was, I covered it up. Can anybody tell me what it is? What is it? 7.5? Thank you. I get tired of moving this calculator. All right, so I got 17.5. They had 17.6. They did a z-score thing, rounded it, whatever. We're good. All right, and it says What do we want to know? Oh, out of 20 flights, right? No? So times 20, we got to move this over to make it from a percent. So 0.175 times 20 flights. So roughly 3.5 flights were, what were we trying to find? The number of layovers that were less than 75 minutes was around 3 or 4 flights. All right, here we go. Question for us, actually. At a restaurant, the average waiting time when you place an order when the entree is served is 12.5 minutes with a standard deviation of 1.2 out of 100 customers served. How many will be served their entree within 14 minutes of ordering? So first of all, let's find the probability, okay, that they're served within 14 minutes. If we did this, 12.5 would be in the middle. One standard deviation up would be 14.7. We added 1.2, 13.7. Somebody help me. And the next standard deviation would be 1.2, more than that, 14.9. So we want to know somewhere in here at 14 minutes, okay, and down within 14 minutes of ordering, right? So 14 minutes or less, everybody good? All right, so we want to say the combined of the bottom, you can default to whatever it defaults to or nothing, okay? From 0 time, right? That would be the shortest time you could get your food in, to 14 minutes, where the mean is 12.5 and the standard deviation is 1.2. All right, so second vars, norm CDF, 0, 14, 12.5, and 1.2. And we get 0.894. That's the probability, okay? I'm going to do this one and this one only by training it to a z-score once. Guys, how do you find the z-score? The time we want is 14 minus the mean, which was 12.5, which gives us to 1.5 divided by the standard deviation of 1.2 is 1.25. So if we went back to norm CDF and we said the lower, what did they have? -1. Well, actually, you could use -4 because that's basically the bottom is 4 standard deviations below. But if you're putting in a z-score, then the mean is going to be we want up to 0.894, where the mean is 0 and the standard deviation is 1. Nope. Well, is that because they use something bigger down here? Or what do you guys use when you do this in class, in AP Stats? The lower. Okay. Do you use z-scores or no? Did I do this wrong? Did someone get something different here? Yeah, I did 9, but why is it so significantly different? Okay. 0 time to 14 minutes with a mean of 12.5 and a standard deviation of 1.2. I had -9. If I get 0.894, but when I do it with the z-score, oh, I put that in as my z-score, dingbat, didn't I? What was the z-score? What was it? 1.25? And we want, is it positive or negative? Positive, right? Did I put it in wrong? So it was like -9 to a z-score of 1.25, where this was, the mean is always 0 and the standard deviation is 1 if you're using a z-score. 0.8943. Okay. It should be the same, and I was freaking myself out. But I didn't put in the z-score there. I put in the probability that we found the first time, which made no sense. Okay. We're not done, though. Sorry. Just do it this way. Okay. But out of 100 customers, how many would be served? 89, because you just multiply this by 100. So you'd have 89 customers would get their food within that time frame. Okay. Miss Kwan, a full-time professor at community college, earns a salary of $48,600. The average salary for a full-time professor is $52,000 with a standard deviation of this. How many of the 45 professors earn less than Mrs. Kwan? Okay. So first of all, we're going to find the probability. Okay. And then we'll worry about this out of the 45. So what are our things here? This is X, right? This is the mean, and this is the standard deviation. So if we want to use the calculator, we just go to normal CDF. I'm not going to bother with a standard deviation, so I'm going to put in, what is it? Earn more or less, or what are we doing here? Earns a salary of this. How many of the professors earn less than this? Okay, so we want less than this. So we could put earn nothing up to $48,600. That's what she earns. Where the mean was what? I am really tired of moving this calculator. Or trying to move this calculator. Where's the mean? 52,000? Oh my gosh, now I covered up the standard deviation. How much? 3,600. Thank you. Okay, so the probability of that happening, that someone earns less than she does, is 0.172. Okay. So we're going to multiply that times how many professors was it? Now that I've covered it up again, 45. So basically about 8. So only about 8 people earn less than she does. During 1 October, the average water temperature in a pond was this with a standard deviation of this. How many days were greater than 50? Oh, now we're going up, right? So we want our minimum to be 50 up to, what do you want to put in as our maximum? As long as you go out more than 4 standard deviations above the mean, you're fine. Doesn't matter. Okay. 53 is the standard. This is it. like about 3. 3 times 4 is 12. Yeah, anything above like 65, 70 would work. Going to give you roughly the same answer. Where the mean is 53.2 and the standard deviation is 2.3. It helps if I write it down, because then when the stupid calculator covers it up, I can... Sorry for coughing on the video. Does this make sense? 91.8%? I don't really know. I have to think about the question, but remember the mean was 53.2, and we're talking 2.3 this way would be 51, 50, I don't know, 50 point something. And this was above 50, right? So it is a big chunk of the graph. Okay. Times October, 31 days. Anybody? 28? Is it 0.5? Okay, so about 28 or 29 days. All right. Average. Okay, this is going to give us a range of values. These are sweet. This first one is really sweet because we get to just type it in exactly like this, guys. 53 to 59 with a mean of 56 and a standard deviation of 4. For this one, we're going to do all the way down below 53. So we could do like 0 to 53 with a mean of 56 and a standard deviation of 4. All right, I'm not using that silly calculator because it'll take me forever. What'd you get? I got 54.7% here. Anybody? And 22.7% here? Yes? Okay. This next part is really cool and I like it, but it's not actually... Some of this next part is we can talk about Monday, but it's not on the quiz, okay? So what you need to work on now, guys, is worksheet 14. The quiz is Thursday next week. And what you need to be working on is 14AB, okay? So we didn't quite finish some things on here, but we finished everything that's on the quiz. And I can go over homework questions Monday, and then I thought we might watch... Oh, I forgot to even show this class this. It's better than a movie. Look it, guys. Miss Abruzzo recorded 5-minute videos on all these different topics that could be on the SAT. So if you want to go home and watch them this weekend, say, okay, I remember how to do systems of equations because we did that in Precalc. But I don't really remember my basic geometry. Watch this video, okay? So on Monday, we'll watch some videos.